Today we will learn about FM modulation, or frequency modulation. FM is one of the most important modulation techniques in communication systems and is widely used in FM radio broadcasting, VHF communication, and audio transmission. Frequency modulation, or FM, is an analog modulation technique in which the frequency of a high-frequency carrier signal changes according to the input message signal, while the carrier amplitude remains constant. Now, let's look at two signals. A low-frequency message signal, which contains the information we want to transmit, and a high-frequency carrier signal, which is used to carry that information over long distances. With FM modulation, the frequency of the carrier changes according to the amplitude of the input signal. When the input signal increases, the carrier frequency increases. At the positive peak of the message signal, the carrier frequency reaches its maximum value. When the input signal decreases, the carrier frequency also decreases. At the negative peak, the carrier frequency becomes minimum. And when the input signal is 0, the carrier stays at its normal carrier frequency with no frequency deviation. Now, let's visually understand the relationship between the message signal and the FM signal through the following example. At the beginning, when the amplitude of the message signal is 0, the carrier frequency stays at its normal value. When the message signal becomes negative, the carrier frequency decreases. And when the message signal becomes positive, the carrier frequency increases. In this example, the message signal is a sine wave, so the frequency changes smoothly and continuously. In real communication systems, however, the message signal is usually an audio signal. That means the FM frequency continuously changes according to the amplitude of the audio waveform. FM radio operates in the VHF band, but the exact frequency range depends on the region. In most of the world, including Europe, the FM broadcast band is from 87.5 to 108 MHz. This is the standard range used by modern FM radio stations. In some older systems, especially in parts of Eastern Europe and the former Soviet region, FM broadcasting also used a lower band from about 65.8 to 74 MHz, but this band is largely obsolete today. So, in modern communication systems, when we talk about FM radio, we usually refer to the 87.5 to 108 MHz range. Now, let's look at the advantages and disadvantages of FM modulation. FM has several important advantages. First, it offers strong noise rejection, meaning it is much less affected by interference compared to AM. Second, it provides superior audio quality, which is why FM is widely used for music broadcasting. Third, FM has good amplitude stability, so variations in signal strength, such as fading, have little effect on the received audio. However, FM also has some limitations. It requires a much wider bandwidth than AM, which means fewer channels can fit within the same frequency range. In addition, FM systems are more complex to design, both at the transmitter and receiver side, which makes them more expensive to implement. Thanks to these advantages, FM is used in many applications. It is widely used in FM radio broadcasting, as well as two-way communication systems like aviation and police radios. It also appears in wireless microphones, telemetry systems, and even some satellite and medical applications, where signal quality and reliability are important. Thanks for watching. I hope this video helped you understand the basics of FM modulation. If you enjoyed it, don't forget to like and subscribe for more RF and communication tutorials.